Okay, hello everyone. I'd like to welcome you to our ChromLab Evaluation Tools webinar. My name is Benjamin Nickel, and I'm one of the chromatography specialists from Bio-Rad Technical Support. Now before we get started, I wanted to go over some basic information regarding the setup of today's webinar. You'll see in the upper right corner of your screen, I've placed a few notes for all of our viewers. I wanted to quickly bring your attention to them. Now, first of all, your microphones are going to be muted to minimize any accidental noise distractions and to ensure webinar clarity. Secondly, for anyone who would like to increase the size of the visual display on your computer, you can click on the full screen button located along the top margin just to the left of where it says Presenter's Notes. And finally, you may submit any questions you have throughout the presentation using the Q&A box in the lower right of your screen. I'll try to address them towards the end of the webinar. Okay, so now let's begin. Now for today's presentation, we're going to be using version 3.1 of the ChromLab software. And ChromLab is a software package that works with our Bio-Rad NGC system to develop, organize, and run chromatography methods, as well as collect and analyze the resulting data. Now, this software is designed to be easy to use, and it also should be fairly intuitive. Now, the title of today's webinar is NGC ChromLab Software: Learn Data Evaluation Tools from the Experts. The goal of today's webinar is to provide you with an understanding of the various tools that are available to you to aid in the analysis of your NGC run data, as well as to enhance the visual presentation of your data. The presentation today will focus on the data evaluation aspects of the ChromLab software. Now, today's presentation is going to cover the following topics. It's ChromLab file organization is where we're going to start, and then we'll move into working with the ChromLab evaluation tools to adjust the display of your data. And we'll talk about the analysis of run files, starting with a single run file and then moving into a comparison of multiple run files. We'll have a discussion about saving the analysis files you may generate, as well as producing analysis reports for any analysis you do. And finally, we'll conclude with a discussion on the column performance evaluation tools. Okay, so now let's switch our view to the home screen of the ChromLab software. Now for today's presentation, we are going to focus on the evaluation section over here of the software, which is used for post-run data analysis. This presentation will not cover the system control or method editor sections of the software. However, if you find you have any questions on these sections, please feel free to contact us at Bio-Rad Technical Support. I'll display the contact information at the end of this presentation. So let's begin by going ahead and clicking on the Open Run Analysis icon shown here. And this opens up a pop-up window asking you to choose the run file you wish to analyze. And the run files are automatically saved under the same project that your method was saved to when collecting data from a method run. The projects are shown here on the left. Now, if you use the system in manual mode to generate your data, the file is going to be located in the project you designated at the time of saving the manual run. Now, within a given project, your run files can be sorted using either the name, start time, end time, or the method. And you'll notice at the bottom there's a tab that says chromatogram. If you select that tab, you'll see a preview of the chromatogram for each of the files that you select. This will help you identify the desired file that you have. So let's go ahead and start by double-clicking on the file of interest, and this will open up the run file. Now, once we're in the run file itself, this takes us to an evaluation tab. Now, from this point, if we wish to view the method that was used to collect this data, we can always go back to that information by clicking on the File menu at the top and selecting Show Method. This will take us back into the method editor and allow you to examine the full method details. Now, if we return to the Evaluation tab, in the File menu, you're also going to notice you'll see options available for exporting the run and/or method files for analysis or import into ChromLab software on a separate computer. Additionally, you can export the chromatogram data in a CSV file format for import into other software packages. Now, if you were to contact technical support with questions regarding your NGC, you may be asked for a chromatogram. Using these export tools will allow you to save the requested files. Now, as we start to look at the rest of the Evaluation tab organization, you'll see the default view is broken into two main sections. You have the chromatogram here at the top, and the data area towards the bottom. The data is presented in a tabular fashion, and you'll see tabs for the analysis of the traces or the fractions that may have been collected during your run. When performing your analysis, adjust which traces are displayed in your chromatogram. Traces can be quickly displayed or hidden using the checkboxes under the Run Traces tab. So let's start by simplifying the view on our file. So we're just going to show the 280 nanometer trace in the conductivity. So we're going to unselect the 215 nanometer trace. Now, if you'd like, you can also change the color of the displayed trace simply by clicking on the color pattern to bring up a color selection. Upon selecting the desired color, we can simply hit OK to apply this selection. So let's go ahead and just change this to a red. Now, this tool will come in handy to aid in trace differentiation later on in the presentation when we start comparing multiple traces. Now, if you wish to zoom in on a specific area of the chromatogram, there are a couple of tools available. The easiest way to zoom is simply using the left mouse button to click on the chromatogram and drag a zoom selection box over the desired area that you wish to focus on. Now, if you wish to unzoom, you can do so by simply right-clicking on the chromatogram and selecting Reset Zoom. Now, if you want to rescale the y-axis, you can do so by clicking on the y-axis settings under the Run Traces tab. So we'll come down here and we'll change that y-axis so we can zoom in a little bit more. We can change that to, say, 400. Now you'll notice that by default, all of the wavelength traces will change to the same scale if any of them are altered. Now if you're displaying multiple wavelength traces and you wish to scale them independent of one another, you'll first need to go into the View menu and uncheck the Lock UV Scale button, which is shown here at the bottom. If you find the y-axis on your chromatogram that's being displayed is not the axis that you wish to have, you can toggle between the display traces simply clicking on that y-axis. So go to conductivity versus 280. Likewise, on the x-axis, you can also toggle between various selections. So currently it's displayed in time, but we can also toggle over to volume in milliliters or to display the x-axis in terms of column volume. Other display features you'll want to be aware of are the checkboxes located here on the right of your screen. Using these checkboxes, you can decide to show or hide information for each fraction collected that's provided fractions were collected during your run. You can also show or hide any events, errors, and or annotations that may have occurred for your run. You can apply annotations to the chromatogram if you'd like using the annotations tool at the top. Simply click on the annotation tool and then drag the vertical bar to the region that you wish to annotate. You can type in whichever text that you desire, and you'll see it will mark your chromatogram. These annotations can be deleted by simply double-clicking on the annotation and hitting the Delete button. Now, many of the features I've discussed so far have concentrated on setting the chromatogram display. Now I want to introduce one of the main analysis tools that's available in the software. This is the peak integration tool. Now, ChromLab has simplified the peak integration to a single click, and to do the integration, you simply click on the peak integration button at the top of the screen. Once selected, you'll see a new tab appear in the data analysis table, which is labeled peaks, and you'll see that down here at the bottom. It's within this tab that the individual detected peaks are listed and their corresponding volume and curve-shaped data are displayed. Now you'll also see that a new menu is opened up on the right of our screen. And in this menu, you can use this for adjusting peak integration using either the auto integration feature or the manual integration adjustments. In auto integration, you're provided an opportunity to adjust baseline detection parameters or peak filtering parameters. Now you can also select or deselect traces that you wish to integrate using the trace checkbox at the top of the auto integration tab, which is located up here. Now currently we can only select one trace, which is the 280 nanometer trace. But if, for instance, we were displaying multiple traces, so if we had our 215 nanometer shown, you would also be able to select that for integrating that trace as well. Now in the manual integration tab, if we go to that, you'll see that we're provided with an opportunity to adjust the left and right boundaries of any of our detected peaks. We can do so by simply dragging the integration bars. Sorry, I dropped my integration here. So as we're back in the manual integration here, we can adjust the integration bars simply by clicking on that and dragging that to the desired location. Now you can also use a right-click button when you're in the manual integration tab, and using the right-click button, you'll see a menu that allows you to either delete peaks, split peaks, add peaks to your integration as necessary. Now these tools, when you're selecting the delete, split, or add peak, these simply are affecting the integration of the peaks. They're not changing the trace data. These can be useful for fine-tuning the integration parameters or for removing any unwanted information from your display. Now once you have the peaks integrated to your specifications, we can go back down into the Peaks tab at the bottom here. And if we know the analyte extinction coefficients, you can have the software calculate a concentration of that analyte for you. So for instance, let's go ahead and take that peak and we'll just put a random extinction coefficient of 1 in, and you'll see the concentration appears. Now we can also carry it one step further and we can add a molecular mass to that analyte. If we do so, the software can then calculate a molarity that has been isolated of that particular analyte. Now after performing peak integration, you can go into the fraction tab and you'll see the individual fraction data is displayed. Now you'll see that fractions with higher analyte concentrations are shown in the fraction collector heat map. And by heat map, I'm referring to the map of the individual fractions on your collection rack. And they're colored to make the proper fraction, identifying proper fractions easier. These heat maps can be colored by area of the curves, by concentration, by amount, by molarity, or you can even color based off of a 280 to 255 ratio if both a 280 and 255 nanometer trace have been integrated. To select between these, you simply use the color by drop-down menu. Now once you're done, the software will auto-save the display parameters, such as selected traces where you've left off, so next time you access any files, you'll see the same settings applied. This will not auto-save the any integration parameters that you have applied to the file. To save those, you're going to have to save the full analysis file, and that will include the peak integration data. You'll want to use the Save Analysis tool, which is located here at the top, for doing that. Once we click on that, it's going to ask you for the name of your analysis file, and if you simply type in a file name, it'll save it in the same location as you pulled up the original run file. You'll see if we go back into the Open Run Analysis menu, you'll see under the Analysis tab the various analyses that we've performed for that particular file. Now before we move on to the multiple file analysis, I also wanted to take a moment to show you the regional statistics feature that is located in the software. This allows you to right-click on a desired region of the chromatogram and simply drag vertical bars across that region. When doing so, you're going to bring up a sub-window that'll display some of the statistics of that selected area. This feature is useful for quick determination or documentation of a region of a chromatogram, or for peak or peaks of interest that may be found. Now, having shown that, I want to turn our attention now to looking at multiple run file analysis. When you would do multiple run analysis when you do features such as scouting runs to try optimizing selection, or if you want to compare the separation of a compound with a previous separation that was done. Now you can open additional run files using the Add Run button on the top of the screen. Once we're in once we open up this menu, we simply select the file or files we wish to add to the analysis to allow a comparison of traces across multiple runs. So let's go ahead and we'll select another run here, and then we'll hit the Add Run button. Now we'll see that it pops up the runs and it shows them in a stacked format. When we look at these multiple run files, the chromatograms can be viewed either stacked or we can select Overlay. And the buttons for those two sections are here at the top. Now when we go to Overlay View, the chromatograms can be offset by adjusting the sliding bar on the left of your screen. Now for adjusting the displayed traces that are shown in your analyses here, it's often more convenient to group the traces by type rather than by run file. So by default, it's going to show each of the traces listed per run. Now to change this, we simply right-click over the Run Traces tab, and we'll select Group by type here. This will simplify the trace adjustment across the runs. So for example, let's go ahead and we'll shut off the 215 nanometer traces in all of the runs. We'll also shut off the conductivity trace here, just so that we're displaying only the 280 nanometer trace. Now you can see using many of the tools that we've previously introduced, you can further refine your display by changing the y-axis of here. So let's zoom in a little bit on these chromatograms. We can also use the peak integration function, and we can do an integration of both traces here. And finally, if we have an area that we really want to zoom in on, we can do so just by doing a zoom feature. So you can see that by using many of the tools that were introduced throughout the presentation so far, you can really bring out the data that you wish to display for the purposes of doing presentations with this data. And you can adjust it accordingly, and you can color the traces using the change in the trace color features. Now, regardless of if you're performing a single run analysis or if you're doing multiple run analysis, when you're finished, you can create an analysis report by going into the File menu, and we're going to select Analysis Report, and you'll see that here at the bottom. Now, once we select that, a pop-up window is going to come up asking you to select the data you wish to include in the report. Once you do so, you simply hit OK. This will generate a PDF analysis report that can be saved, or it can be used for electronic record keeping. For other ways to save your data, you can copy the chromatogram by right-clicking on the chromatogram and selecting Copy Chromatogram. This allows easy import into programs such as Word or PowerPoint by simply pasting into these programs. There are also save functions to allow saving the chromatogram. As you can save the chromatogram here as a PNG, a JPEG, a GIF, a TIFF, or a BMP file. Likewise, for the data table, we can right-click on the data table and use the Copy Table feature to facilitate import into other software. Now there's one more tool that I want to introduce you to, and that is the Column Performance Evaluation tool. Now this tool can help with performance comparisons between multiple columns or analysis of performance over time. Now to use this tool, we first have to open up a run file where a column performance test phase was incorporated into the method. So let's do that. We're going to come into the Open Run Analysis. Now once open, you can go into the Analysis menu, and you can select Analyze Column Performance. If you look at the menu on the right, it'll prompt you to select the calculations you wish to perform. Here we can calculate column performance based off of conductivity trace. Here we're going to actually calculate it based off of the conductivity trace. Sorry. The software will calculate the number of theoretical plates for the column. If you provide the resin bed height, you can also calculate the number of plates per meter and the height equivalent per theoretical plate. So we'll go ahead and we'll actually put that in. So we'll call this a 30 centimeter column. Now, if we're also interested in the reduced plate height calculation, you're going to need to know the average particle diameter of your resin to do that particular calculation. Once all the appropriate calculations are selected and the column properties are input as necessary, simply hit Apply. You'll see that the column performance data tab, all the values for these calculations will be listed. Now you can also find in this tab information regarding the peak symmetry. Now you see that much like the peak integration features that we've previously introduced, the column performance evaluation allows manual adjustment to these peak boundaries. You can do so in the Manual Adjustment tab. And we do the adjustments just like we did previously with the peak integration, simply by sliding the boundary lines. When we're finished, the data can be printed using a Run Report option available in the File menu, very much like we did with the analysis report. Okay, now at this point, we've covered the available tools in the ChromLab software that will help you in your analysis and the visual presentation of your data. We've reviewed the run file organization, the information on adjusting the data display, and how to analyze the run files. We've also talked about saving the analysis and generating reports. Now, as you start to work with your ChromLab software, you're always welcome to contact us at Bio-Rad Technical Support by phone or email should you need assistance. Place the contact information on the screen. Now, I'd like to take a few moments to address any questions submitted from our audience.